the textbook definition of Newton's third law is for every action there's an equal and opposite reaction. Now, a good example of this is just something everyone does. If I rest my hand on the table, my hand doesn't go through the table. I'm exerting a force on the table by pushing downward on it, but at the same time, the table is exerting a force on me. So, no matter how hard I push on this, I'm not going to go through the table, because there's that exact same level of force pushing back on me. And objects cannot exert forces on themselves. A good example of this is, think of your hand. This doesn't count, but how would you exert a force on your own hand with just that hand? You can't. You can't push on your own hand with your hand. So, whenever there is something pushing on an object, the object itself is pushing back on it, but it cannot exert a force on its own. Alright, so before we begin, I'm going to kind of explain how matches work. So, there's a chemical on here and a chemical on here. Now, when we strike them, they mix and they cause a combustion reaction. Now, as you can see at the end there's that smoke. That's one of the signs of the reaction. That's what's going to be driving our match rocket. Alright, today we're going to be making match rockets, and to do it you're going to have to snap off the match head. If I can do it here. There we go. And so this way we have the smallest surface area possible. Now next, you're going to take a paper clip, a piece of small tin foil, and the match head, put them together like so, and then wrap them in tin foil. Try and get them to stay next to each other, because the paper clip is the landing platform for the match rocket. Now when you wrap it, you have to try and leave a small area for a vent out the back. And what this does is, when the match inside creates the gases as it ignites, it will push against the tinfoil inside of the match head and then out the back, propelling it forward. Equal and opposite reactions. So after you have it wrapped up nice and neat, get a match, and we're going to light it off. That's how we do it, boys. So, we have our match rocket here. And the reason why this works is because there's a force from the igniting of the match inside pushing on the tinfoil. But at the same time, the tinfoil is pushing back on the match itself, because equal and opposite reaction, you have a force here, something has to meet it. Now, the reason that we had to leave an exhaust vent when we made it was so that there could be a force pushing outside and not just being contained inside the little ball. And so with that exhaust vent, there's a force pushing here, and then there's also a force pushing here, coming out the back, and what that does is it accelerates the match forward. Now, we're doing this with matches and tinfoil, but think of it with like a balloon. If I blow up a balloon and I'm holding it here, I don't seal it or anything, and I let it go, the gas inside of the balloon is going to push out the back, and it's also going to be pushing on the balloon, and so it's going to go forward. Now, that concept is how rockets work, like real rockets. You have the ignition of the fuel, which pushes up on the rocket, and then the thrusters on the ground push down on the ground pushes up on it, and it accelerates it up in the air. And that is Newton's third law.